Hello, friends. This today's practice is a little bit something different. It's a graphic representation of how much different substances can dissolve in water at different temperatures. So it's called a solubility curve. That's what this graph is here on this assignment. Okay. So let me point out some features of this thing to you before I look back at the questions. Down here on the x-axis, you have temperature in degrees Celsius. This can on a lot of graphs you can change what's on the x and the numbers and the range and everything, but for this particular kind of graph, because what we're talking about here is how much stuff can be dissolved in water, like liquid water, that's the only range you can have. Because at 0 degrees Celsius, water doesn't stay liquid, it turns into a solid. And at 100 degrees Celsius, again, water doesn't stay liquid, but this time it turns into a gas. So the temperature is always going to be on this x-axis, and it's always going to be between 0 and 100 degrees Celsius on this kind of graph, a solubility curve. Now over here on the y-axis, you have grams of solute per 100 grams of water. So for every 100 grams of water you have, these numbers tell you how many grams of whatever it is you're trying to dissolve, the solute, will fit in the water, so to speak. Okay? And we're going to talk about what it looks like. There's some special words we use to describe solutions that have got more room for more stuff, or are full up, or maybe have more stuff in them than they really should. But we're not gonna, that's a look ahead later this week. Okay, for right now I want to just focus on making sure you can read this thing in the first place. Okay, each one of these lines represents a different substance, and they're labeled with their names, or their formulas for the different substances. You don't have to be able to say the substances by name. If you can just name them by their letters or their formulae, then that's perfectly fine. All right. So let's take a look here at the questions. All right. You'll notice it says that for most substances, solubility increases as temperature increases. And you probably did notice that if you worked on the activity on Thursday. When you increase the temperature of water, you can dissolve more stuff in it. That's what, like we were talking about with the difference between sweet tea and unsweet tea. When you order unsweet tea and try to sweeten it with sugar, that doesn't work very well because the tea is cold and it doesn't dissolve as much sugar as the hot tea does when you're brewing sweet tea. Okay, as discussed earlier, in solutions involving liquids and solids, typically more solute can be dissolved at higher temperatures. This is important. Okay, we're talking about when you're dissolving solid stuff in liquid water. There is an exception indicated on the graph, okay? And it's down here. You'll see all these lines pointing up tell you each one of these things can get more stuff dissolved in the water the hotter it is. But this thing right here, NaH3, goes down. I think actually there's another one that goes down too. Yeah. It's because they're gases. Okay? They're gases. And so gases dissolve less easily in hot water than cold water. We're not too worried about that, but I want you to know that's why those lines are pointing down, because they're gases. Okay? So when you're looking here at the exception, name an exception. Line decreases with temperature increase indicated on the graph. And I'm going to fill it in for you right now. Right? It's NH3. No. Okay. I'm going to highlight that for you because I want you to know that's an exception. Okay. Here's an example of how to read the graph. Find the curve for KClO3, which is called potassium chlorate. Okay, potassium chlorate. Here it is. Down here, close to the bottom. This curve right here. Potassium chlorate. All right. At 30 degrees Celsius, approximately 10 grams of potassium chlorate will dissolve in 100 grams of water. If the temperature is increased to 80 degrees Celsius, approximately how much of the substance will dissolve in 100 grams or 100 milliliters of water? This is a weird thing about water that's not true about a lot of other substances. The amount of grams of water are equal to the number of milliliters in liquid water anyway. It's not true for solid or gas water, but for liquid water, that's true. But that's a weird thing about another thing in the list of things about water that's weird. Okay, so coming back down to the graph here to potassium chlorate, it says at 10 degrees or 30 degrees Celsius, we can dissolve about 10 grams. So let's check if that's true. Here I'm at 30 degrees Celsius. And yes, the curved line that's for potassium chlorate crosses this 10 grams of solute per 100 grams of water here at the 30 degrees mark. So yes, it's true that about 10 grams of potassium chlorate can be dissolved in this water when it's 30 degrees. But the question is asking how much can it dissolve at 80 degrees? So now I move over to this 80 degrees and I'm going to follow the line on up. And now here it's touching the potassium chlorate line. So I'll move on sideways to the y-axis and I see it's at 40. 40 grams of potassium chlorate can dissolve in 100 grams of water. That's at 80 degrees Celsius. Okay? And that's how you do that. You follow the lines and see where they intersect. Okay? So you need to try that yourself for these different substances. And I'm really like stopping there because I want you to mark this thing up, okay? I want you to you can't mark it digitally, I know. I mean, if you figure out a way to do that, great. But I need you to print this for yourself if you can. I need you to try this for yourself. I want you to be able to understand here what's going on with this and be able to read it, because the next part is not just looking at this line and like finding, okay, at this temperature how much of this stuff can I dissolve, or how much what temperature I need this water to be to dissolve this much stuff, right? I also need you to be able to identify if the solution could dissolve more, or if it's right at as much as it's supposed to be able to dissolve, or if I can make it dissolve more, if I can force it to dissolve more than it really ought to be able to do. That's a whole different thing, okay? So start here, start with this, and I'll also post another video for you to watch to practice with this concept, okay?